Hello everyone, I'm Dr. Priya Hassan, and today I'll be talking to you about our astrobits on the recent May 2024 solar storms. I'm sure you may have heard about it or seen some pictures about it. So actually in May 2024, that is this month itself, there were a series of powerful solar storms with extreme solar flares and geomagnetic storms that occurred between approximately the 10th to 13th of May. And this is the solar cycle number 25. And the geomagnetic storm was the most powerful to affect the Earth since March 1989 and produced aurorae at far more equatorial latitudes than usual, both in the northern as well as southern hemispheres. So let's try to understand this in a better way. First of all, let's start off with the first question. Is the sun a variable star? And what is the solar cycle? So the sun is an extremely constant star, and its brightness and activity are very, very constant. And many stars actually have pulsations where you have a very large difference in their size and brightness. So, but there is a variability in the sun, which is literally of the order of 0.1%. Okay, that is the variability which takes place in the course of 11-year-old solar cycle. And this solar cycle is also called the solar magnetic activity cycle or the sunspot cycle. And it's approximately 12 years, it's a 12-year period. And what basically happens in this period is that the levels of the solar radiation, ejections from solar material, number and size of sunspots, all of these vary at this approximate period of 11 years. And essentially, the magnetic field of the sun, it flips during each solar cycle. And therefore, you have 11 year and 11 year. So after 22 years, you'll actually have the magnetic field as it was. So here you can see this plot. This is a plot of about 400 years of sunspot observations where you can see there's a rise and the fall, and it approximately follows this kind of a 11-year cycle in this thing. There are also these interesting diagrams which are called the butterfly diagrams. Butterfly diagrams are basically showing the movement of sunspots in the terms of latitudes. So what you see on the y-axis is the latitude, so 0 is the equator, and you can see as time progresses, these sunspots move towards the higher latitudes. And you can actually see the sunspot area, how it actually increases with time. So the solar cycle 25, it actually began in December 2019, and there were various predictions made about it. People knew it was an active cycle of the sun. And if you see in this plot, there is a Maunder minimum, which did occur in the 1600s. But it was expected that here we won't have a Maunder minimum, but it's a reasonably active thing. Now, let's jump a little bit and talk about what are aurorae. Now, aurora is actually, you either call them the northern lights, aurora borealis, or the southern lights, or aurora australis. And it's basically what it is. It's a natural light display in the sky, where you actually see dynamic patterns of brilliant lights, which look like, curtains, rays, spirals, kind of flickers across the sky. And what basically happens is here you have the sun. The sun gives us solar wind, which has charged particles. The Earth has its magnetic field, which creates this magnetopause where you can see. So what happens is the solar wind particles can fall onto the Earth only along the poles. The rest of the Earth is kind of protected or covered up or shielded because of the magnetic field. Now, so this is basically a result of disturbances in the Earth's magnetosphere, which are caused by the solar wind. And major disturbances occur in environments depending upon the speed of the solar wind as well as the magnetospheric plasma. Now, a lot of the planets in the solar system, even natural satellites, brown dwarfs, they also do show these auroras. And here are some very beautiful pictures of auroras. So basically, like I said, it's in high latitudes in the north or the south, where you have these kind of effects on the sky, which look like curtains or rays. So they could be green and in various colors, according to them. So they typically occur in the auroral zone, which is about 3 to 6 degrees wide in latitude, between 10 to 20 degrees from the geomagnetic poles. Okay, and they are actually, like I said, they are caused by energized particles from the sun, which enters the Earth's atmosphere and creates these things. And you have different colors. So, for example, the green auroras are caused by oxygen molecules at a height of about 100 to 300 kilometers. Red auroras are caused by oxygen at 300, 400. You could also have different kinds of molecules which are causing these kind of different. Blue and purple auroras are also caused with nitrogen particles, etc. Now, what actually happened in May 2024? You basically saw there was a huge increase in geomagnetic storms leading to spectacular aurora displays. Now, if you can look at it, typically these northern latitudes are where you're actually going to see the aurora. But because it was so intense, therefore it was observable. This is here's Canada and here's the US of A. So you can see that even in more southern latitudes of the USA, you could actually see it. And this is a real picture seen from Vermont on 11th May, where you can actually see these beautiful things. Now, the current solar storms have not caused any damage, though there were some power grid irregularities. And but obviously we need to be aware of these storms, of these activities, because they have a direct effect on life and communications and various other activities taking place on the earth. So do have a look at some of these very beautiful pictures which people got in this period when we had these geomagnetic storms. Thank you.